Today we're going to use multiple strategies for multiplying a fraction by a whole number. We'll start with a word problem. Mrs. Taylor wants to feed each of her 3 kittens. She will need 3/4 cups of cat food for each kitten. How many cups of cat food will Mrs. Taylor need? In the center of this model, I can solve this problem by multiplying 3, because there are 3 kittens, by 3/4, because each kitten will need 3/4 cups of food. So we're going to multiply 3 by 3/4. To solve this problem using algorithm, I can turn any whole number, like the number 3, into a fraction by placing it over 1, because fractions are division, and 3 divided by 1 is the same as 3. It's equal to 3. To solve this problem using algorithm, I will first multiply across the numerators. And if I multiply 3 times 3, I get 9. Then I will multiply across the denominators. And if I multiply 1 times 4, I get 4. This gives me an improper fraction. Because fractions are division, I can divide 9 by 4, because my numerator is my dividend and my denominator is my divisor. I know that 4 times 2 is equal to 8, and 9 minus 8 equals 1. So 9/4 is the same as 2 and 1/4. Now, I can use several other models to help me solve this problem. If I know that I have 3 cats and each cat is going to need 3/4 cups of food, I can use an area model. I can show my 3 cats, 1, 2, and 3, and then I can draw a model to show that each cat will get 3/4 cups of food. So I need to split my model into fourths so that each one of these squares represents 1/4. And then I will show how each kitten will be eating 3/4 cups of food. And I can do that by coloring in the amount that each cat will be eating. So 1/4, 1/4, and 1/4 equal 3/4. So the first kitten will have 3/4 cups. The second kitten will have 3/4 cups. And the third kitten will also have 3/4 cups. Now, if I count all the quarters, I have 3 quarters here. With another 3 quarters is 6 quarters. With another 3 quarters is 9 quarters. And again, because fractions are division, if I divide 9 by 4, I end up with 2 and 1/4 cups. I can also show repeated addition in a similar manner. I can show cat 1, cat 2, and then cat 3. And these are kittens. So I can show that this cat will have 3/4. This cat will have 3/4. And then this cat will also have 3/4. Now, I know that in order to make one whole, I need 4/4 because 4 divided by 4 is 1. So I can come over here and I know that here's 3/4 and here's another fourth. This is one whole. Here's 2/4 and another 2/4. And that makes a second whole. And then I know that I have 1/4 left right here. So if I add, if I add 1 whole and 1 whole and 1/4, then I get 2 1/4. I can also show this multiplication on a number line. I know that my answer is going to fall somewhere in between 0 and 3. So the 1 would be about here, here's 2, and there's 3. So I know that when I have 3 times 3/4, my fractional amount has a denominator of 4. So we're going to divide each whole into 4 parts. So each one of these is going to represent a fourth. So this is 1/4. This is 2/4, which is the same as 1/2. This is 3/4. This is 1 whole, which is the same as 4/4. Here's 5/4, which is the same as 1 1/4. Here's 6/4, which is the same as 1 2/4, or 1 1/2. This is 7/4, which is the same as 1 3/4. And here's 8/4, which is the same as 2 because 8 divided by 4 is 2. Here's 9/4, which is the same as 2 1/4. Here's 10/4, which is the same as 2 2/4, or 2 1/2. Here's 11/4, which is the same as 2 3/4. And here is 12/4, which is the same as 3 because 12 divided by 4 equals 3. So I know that I'm going to have to jump 3/4 3 times because multiplication is repeated addition. So I am essentially saying 3/4 plus 3/4 plus 3/4 equals 9/4. So I'm going to show those jumps on my number line. I'm going to start with 0 and I'm going to make 1 jump of 3/4 to show how much one cat is going to eat. The next jump will land me at 6/4 to show what the second cat will eat. And my third jump shows me another 3/4, which is what all 3 cats will eat together. And that is 9/4, or 2 1/4. And those are 4 different strategies for multiplying a fraction by a whole number.